I next want to introduce the matrix transpose. This operation is pretty much very different from anything you've seen in multiplication of real numbers. In fact, when you try and make sense of it for a one-by-one matrix, it doesn't really do anything. So why care about this matrix transpose? Well, one of the main uses for it is to convert between row and column vectors. And the second main use of it is to allow us to write the dot product in terms of matrix multiplication. And it turns out that that's pretty useful. So what is the matrix transpose? Well, let's make a definition. Definition. The transpose, let's put a little squiggly under there, of an m by n matrix A is the n by m matrix A with a little t up top there, it's a capital T, whose ij entry is a j I. So notice the order here is changed. Okay, so what does it do visually? Let's look at some examples. When I take the transpose of this matrix here, all I get is this one here. In other words, all the rows become columns and the columns become rows. The transpose of this matrix here is this matrix here. And the transpose of this row vector is the column vector 5, minus 1, 2. So that's what I meant by row vectors and column vectors being converted into one another by the matrix transpose. I also said that the dot product can be written in terms of matrix multiplication by using the transpose, and here's how. So let's let U be the column vector u1 through un, and let's v be the row vector v1 through vn. Then u dotted with v, that's the same as u1 v1 plus dot 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 plus un vn, which is u1 un, so that row vector, row matrix, times this column vector here. Now, I'm being a little sloppy. Technically, I should have these brackets here, but for many purposes, we usually will leave those out when it's just a number. So usually when we're writing a one-by-one matrix, unless we want to specifically emphasize that we're dealing with a one-by-one matrix, we'll just write a one-by-one matrix as a number. It's just without the brackets. Okay, so here I have this guy times this, but that's the same as the transpose of this guy u times, using just normal matrix multiplication, times v.